In this video, we're going to just discuss a little bit about notation. And so there's a new notation that I'm going to introduce here that I've slightly introduced in one of the other videos, and that's the Leibniz notation. And this notation is really useful, particularly in Calculus 2, even in the end of Calculus 1 where you're dealing with integration. So let me explain how this works. We've said so far that f prime of x was equal to the limit as delta x goes to 0 of f at x plus delta x minus f at x all over delta x. Another way of thinking about this is the limit as delta x goes to 0 of the change in y, because that's really what this is the change in y over the change in x. Now the idea here is this: as delta x goes to 0, this thing becomes increasingly small, in fact infinitely small, but it's not quite 0. So we replace that with the following. We say that the limits as delta x goes to 0 of just delta x, we call that dy. And then we say that the limits as delta x goes to 0 of delta y, that's, oops, I wrote dy up here, that should be dx. And this is dy. What we're saying is that as these guys, as this goes to 0 and this becomes increasingly small, we just call this dy dx. So an infinitely small change in y over an infinitely small change in x. Now we could debate whether these guys exist as what are called infinitesimals. And if you're interested in learning more about that, you can read a book by Abraham Robinson. Okay, but again, it's not that big of a deal. In fact, for this course, we won't be thinking about it as a ratio, okay, because that's not how we've really defined this. We've defined this to be equal to this. So in general, when we say f prime of x, this symbol dy dx is the same thing. They're replaceable with one another. And so dy dx is the limit as delta x goes to 0 of the change in y over the change in x, which is the same thing as the limit as delta x goes to 0 of f at x plus delta x minus f of x over delta x. Okay, so big idea is that this dy dx stands for the derivative of the function at x. Okay, or at whatever, I shouldn't say necessarily at x because it depends on where it's defined, but this stands for f prime. Okay, so one of the ways that we could use this is we could say something like this: if f of x was equal to, let's say, x squared, and we wanted to find f prime of x, what we're looking for is dy dx, and more importantly, we're looking at ddx of x squared. This right here says that we're going to, this is like an operator, or you can think about maybe like a function, I guess, but this tells us that we're going to take the derivative of x squared with respect to x is exactly the same as f prime of x. So either of these notations, these guys mean the same thing, and this just means you need to go ahead and eventually take the derivative. I'm going to be using this notation a ton throughout the course because it's very common to be used in a calculus course. Don't get too wrapped up on this prime notation right here, because this Leibniz notation is going to be much more useful as we go through the course.